Hello and welcome to this module on poisoning attacks. I'm Harry, and today we'll be diving into one of the most concerning forms of attacks on AI systems, poisoning attacks. These attacks are directly going to target the data that AI models rely on to learn, which makes them particularly dangerous. By the end of this session, you'll have a solid understanding of what poisoning attacks are, how they work, and what you can do to mitigate them. So let's get started. So what exactly is a poisoning attack? In simple terms, poisoning attacks involve introducing malicious data into a training set that AI models will learn from. The goal here is to tamper with the integrity of the data, ultimately corrupting the AI model. The key concept of poisoning attacks is that it affects the data and not the model itself. The attacker will manipulate the data in such a way that the model learns the incorrect patterns or behaviors. This can lead to outcomes such as model corruption, where the AI learns incorrect information, and influence, where the attacker manipulates how the model behaves in specific scenarios, as well as degradation, which reduces the model's overall accuracy and reliability. So now let's talk about why attackers would use poisoning attacks. One common motivation is sabotage. An attacker might intentionally corrupt the model's performance by introducing bad data, rendering the AI unreliable or even dangerous in critical applications. Another motive is misinformation. By introducing false or misleading data, an attacker can spread inaccuracies through the system, leading to flawed predictions or decisions. Finally, some attackers aim to alter outcomes. This is where they can manipulate the model to produce specific results, often for personal or financial gains. Let's explore the techniques used in poisoning attacks. Attackers can inject data that introduces bias into the system. For example, by altering the distribution of certain data points, the AI could develop a skewed or biased understanding of the world. They can also introduce incorrect data. Would typically be data points that are factually wrong, but the model will treat them as legitimate information. Another model involves misleading data. This would be data that is crafted to steer the model into the wrong direction, causing it to make poor decisions. Additionally, label manipulation is very common. This is where attackers change the labels on otherwise correct data points, causing the model to learn incorrect association. Some advanced techniques include backdoor attacks. This is where hidden triggers are embedded within the data itself. These triggers activate malicious behavior when encountered by the model. There's also gradient-based poisoning, which involves using the model's gradients to determine effective points to poison. And then lastly, there's feature injection, which is when attackers add data that exploits specific features the model is sensitive to. This would further distort the model's behavior. So what's the impact of these poisoning attacks? Why do we care? First, they lead to incorrect learning. Where the AI model learns and generalizes from the patterns, that would be completely wrong. This can have a cascading effect, where future predictions are also going to be flawed. There's also reduced accuracy. This would mean the model's performance will suffer because it's been trained on compromised data. Even worse, these poisoning attacks can lead to security breaches, where attackers exploit these vulnerabilities even further. Over time, this attack can erode the system and the trust that people have in the system. Overall, people begin to lose confidence in the AI system, especially in areas like healthcare or finance, where accuracy is going to be absolutely critical. So now let's look at some real world examples of how poisoning attacks can affect different AI systems. One example is recommendation systems. Imagine an attacker is manipulating the data that drives recommendations on an e-commerce platform. They could promote specific products or services by poisoning the model to favor those items over others. In the case of financial models, attackers could introduce biased data that affects predictions in the stock market, leading to inaccurate forecasts or even manipulating the market trends. Finally, in healthcare AI, poisoning attacks can have life or death consequences. If incorrect patient data is inserted into the diagnostic models, it could lead to misdiagnoses or incorrect treatment recommendations. So, how do we defend against poisoning attacks? One of the most important steps is data validation. Rigorous validation processing helps us to detect and remove malicious or incorrect data before it ever reaching the training set. This can also use robust training techniques that are designed to withstand attempts at poisoning, such as differential privacy or robust statistics. And then anomaly detection is another critical tool. It helps identify unusual patterns in the training data, which could indicate an ongoing poisoning attack. It's also essential to ensure the data collection is a secured process. This means maintaining data integrity from the moment it's collected throughout to the model's training. Regular and periodic reviews are important too for the model, where we review and retrain models with verified clean data. Lastly, adversarial training can strengthen models by incorporating adversarial examples into the training process. This would make the models more resilient to poisoning attacks. In summary, poisoning attacks target the data that AI models rely on, introducing malicious elements to manipulate outcomes. These attacks have significant impacts, from reduced accuracy to security breaches and loss of trust in AI systems. However, by employing rigorous data validation, robust robust training techniques, and anomaly detection, we can mitigate some of these risks. So thank you for joining me in this session for poisoning attacks. In future modules, we'll explore some other types of adversarial attacks and how we can defend AI systems against them. See you next time.